This is part 3 of our video on power rule. So we stopped before we got to E and F. So for question E, I have h of x equals x to the power of 5, and then that's the square root of x to the power of 5. So in order for us to take the derivative of this, I need to try to write that root as a power. So roots come from fractional exponents. So that means that h of x is x to the power of 5. The 5 is just a regular exponent. And then this is a square root. So that is going to be divided by 2. That was something that you learned in grade 11. And if you look up at the front board, you'll see that there are signs up there that show the rule for roots and fractional exponents. Once this is written as a power, I can take the derivative. So we're going to do h prime of x since it's written in function notation. We are going to take the exponent, multiply by that secret coefficient of 1. So 1 times 5 over 2 is just 5 over 2. And then I have to subtract 1 from 5 over 2. You could use your calculator if your calculator does fractions for you. Otherwise, I'm going to do 5 over 2, take away 1. In order to subtract, I need a common denominator. That 1 is currently over 1. So this is going to be 5 over 2, take away. A good common denominator would be a 2. So I would have to multiply the top and bottom by 2, and I would get 2 over 2. So 5 over 2, take away 2 over 2 is 3 over 2. So my exponent here would be 3 over 2. Now, if the original question was written with a fractional exponent, you should write your answer with a fractional exponent. If the original question was written as a root, we should write this as a root again. So the 3 is just the regular exponent. It's the denominator that is the root. So that means that h prime of x is going to be 5 over 2 times the square root of x cubed. If you want to put the 2 in to show that it's a square root, you can do that. But square root, we normally just don't put a number there, right? Either one is fine. Okay. All right, we've got one more here. So we have f says y equals 1 over the cube root of x. So not only is this a fractional exponent because of the root, it's also a negative exponent because it's a fraction. So before I do the derivative, I want to rewrite this as a power. So I think I'm going to start by writing it as an exponent instead of the root. So this is going to be 1 over the cube root of x is x to the power of 1/3. So this does have a secret exponent of 1, right? And then the 3 is going to be our denominator in our exponent. And then because it's a fraction, this is going to be x to the power of -1/3. Now, if you're capable of doing that in just one step, that is fantastic. All right, so we are going to take the derivative. So I'm going to do dy by dx. You could do y prime if you really wanted to. We're going to take our exponent times our coefficient, which is a secret 1. So I'm going to get -1/3. And then x to the power of, I need to do -1/3, take away 1. That 1 has a secret denominator of 1. I need a common denominator, so I'm going to go for 3. So I don't do anything to the first fraction, but that second one, I'm going to multiply top and bottom by 3. So -1 take away 3 is -4 over 3. So my exponent here is going to be -4 over 3. Okay, so because the original was a fraction, it didn't have a negative exponent, and it was a root, I need to put it back in that format. So the order in which you do is up to you. I think I'm going to do the reverse order of how I did this in the first place. So I'm going to deal with the negative first. The negative exponent makes a fraction. I already have a fraction in front, so that x is going to move down into the denominator with the 3. So this is -1 over 3x to the 4/3. And then that power of 4/3 is only on the x. So this is going to be -1 over 3. And then this is going to be a regular power of 4. And then that's going to be a cube root. So it's 3 times the cube root of x to the 4th. And there's my derivative. Okay, our last page, we've got some graphs. So it says here, a tangent is a line that touches a curve at one point. The slope of the tangent matches the slope of the curve at that point. So when we are finding our derivative, we are finding the equation of the slope of that tangent line. So it says, find the equation of the tangent line to the curve y equals 3x squared plus 5x minus 1 at x equals -1. So we're trying to find the equation of a line. Now, thankfully, it's not a vector equation or a symmetric equation or a parametric equation. We are looking for the scalar equation, or just y equals mx plus b. So that's what I'm going to start with. I'm going to start with y equals mx plus b. Now, if I want to write my equation in that format, I need m and I need b. M is our slope and b is our y-intercept. So to get m, that is just slope. Slope we can get by doing our derivative. So I'm going to start by trying to find the slope. We'll use a different color for that. And we're going to do that by trying to find our derivative. So I have y equals 3x squared plus 5x minus 1. So that means dy by dx, or y prime, your choice, is 2 times 3, so 6. And then if I take 1 off, I get x to the power of 1. So I'm actually just going to write x. Okay, 5 times x. If I take the derivative of that, that currently has an exponent of 1. So 1 times 5 is 5. And then if I take 1 away from my exponent, I get x to the 0. Anything to the power of 0 is just 1. And if I do that times 5, it's just 5. And then here, the -1 is a constant. It technically has an x to the power of 0. 0 times -1 is just 0. So that term is going to go away. So my derivative is just going to be 6x plus 5. Now, that is the equation of the derivative, or the slope, at any point on the curve. Specifically, I want x equals -1. So I'm going to try to calculate the slope when x equals -1. So I'm going to get that dy by dx is 6 times -1 plus 5, meaning my slope that we're trying to find is -6 plus 5, or -1. So our slope for our equation is -1. Okay, so I now know the slope. To get the y-intercept, we didn't do a lot of this in our unit because we mostly did vector equations, and then we would follow the circle to get to the Cartesian or the scalar one. But to find the y-intercept, I can just take my slope, and I can take a point, and I can slub it into that equation and calculate the y-intercept. So I would do y equals mx plus b. I know that m is -1. I know that x is -1. I would like to find b, but I'm missing y. How could I find y? Well, I could sub -1 into my equation and calculate the y. So to get the y value, I would do 3 times -1, right? That was my x squared, plus 5 times -1 minus 1. And if I calculate that, I get 3 take away 5 take away 1, which is -3. So I'm going to put -3 in here, and then we should be able to calculate for b. So -1 times -1 is +1. And then I'm going to subtract 1 from both sides to get that -4 equals b. So that means my equation is going to be y equals m, so -1, x, and then plus b. So since it's negative, I'm just going to write -4. Okay, I think we're going to stop there. We will talk about those graphs on another day, or you can look at the filled in solution on Brightspace. Okay, have a good rest of your day.